Okay, so today we're going to talk about the third way to solve a system of equations, and that's through elimination. So when you're using the process of elimination, you're basically looking for a variable that you can eliminate by adding together the two equations in your system. So the first thing you always have to look for if you're going to use elimination is to make sure that your variables are lined up, meaning you have your x's on top of x's, y's on top of y's, and equal sign on top of equal sign, and constant on top of constant. And in this case, we're all lined up, and that's how we need to be. And then you're looking for a variable that will be able to cancel out if you add these two equations together. So for instance, if I add 2x plus 3x, I get 5x. So that doesn't help me to eliminate the x's. But if I add positive y and negative y, those are going to cancel out because a positive y and a negative y give me 0. So that's the exact thing that I need to find. So let's try that. I'm going to take these two equations and I'm going to add them together. 2x plus 3x equals 5x. Positive y and negative y are going to cancel out. Equals 9 plus 16 is 25. Okay, so now what I see is I have an equation that I know how to solve because there's only one variable in it, x. That's 5 times x, so I know to undo 5 times x, I need to divide by 5. Do that on both sides, of course, and x equals 5. Now remember, a solution to a system of equations is a coordinate. Some x comma y value. So right now I only have the x. I need to figure out what the y is. Well, that's easy. I can find y by substituting this x value back into one of these two equations. And it really doesn't matter which one I use. So let's try the first one. 2x plus y equals 9. Right? And so for every x, I'm going to replace every x with 5. Okay, so let's see what happens then. 2 times 5 plus y equals 9. Okay, let's do the math. 2 times 5 is 10 plus y equals 9. Now I need to solve for y, so I just use inverse operations. I need to get rid of this 10, minus 10, and I get y is equal to negative 1. And now I have my y value. Right? So if I want to write the solution to this system, my answer would be 5 comma negative 1. And just to show you that this would work in this same equation, it doesn't matter which one you pick, here, 3x minus 1 equals 16. Again, I'm going to replace my x with the value of 5. So 3 times 5 minus y equals 16. 15 minus y equals 16. Okay. I'm going to subtract 15 from both sides. Careful, because I have a negative y is equal to 1. I can't have a negative for my y. That's a negative 1, basically, right? I'm going to divide by negative 1. Y is equal to negative 1. Same thing. Okay? Awesome. So let's try that. Let me give you another example, right? Let's take a look. First things first, always make sure you're lined up. My x's are lined up, my y's are lined up, my equal signs are lined up, and my constants are lined up. So I'm ready to go on this one. I need to make sure that there's a variable that will cancel out if I add these together. Okay, 5x plus 3x, that's not going to cancel out. But negative y and positive y will cancel out. So this is a perfect system of equations to use elimination. So let's just add them together. 5x plus 3x, 8x. Negative y plus y is going to cancel out and give me 0 equals 12 plus 4 is 16. So I have what I want, an equation that I can solve that has only one variable. Okay, 8x equals 16, so I'm going to use inverse operations. I'm going to divide by 8, and x is equal to 2, right? But remember, my solution has to be an xy coordinate. So I only have x right now, so that means I need to find my y. And I can find my y by substituting it into any of these equations. This one or this one. I'm going to pick this one because it looks a little bit easier. It's got addition in it, so why not? Let's do 3x plus y equals 4. I'm going to substitute in my x value of 2. So for every x, I'll replace it with a 2. And I'm going to solve for y. So let's do 3 times 2 is 6, plus y equals 4. I'm going to subtract 6 so I can get y by itself. Y equals negative 2. So there's the other part. And my answer for this is 2 comma negative 2. That's my answer. Okay. I could, of course, check this by going back to plug any of these numbers, right? To plug in these two numbers in here, and I should get a true statement, right? So if I want to check my work, let's say I'm taking a test, and I just want to make sure, right? I'm going to use this as my x and y values. So here, 5x minus y equals 12. So this is the first equation. If I plug that number in, I should get a true statement. So 5 times 2 minus, I gotta be careful, this is a minus a negative 2 equals 12. So that's 10, negative, and negative is gonna be a positive, equals 12. 12 equals 12, so that's my first true statement. But remember, a solution has to work in both equations, so let's try this one. 3x plus y equals 4. All right, my x value is 2. My y value is a negative 2 equals 4. This is 6 plus a negative, so that's minus 2 equals 4. 4 equals 4. So I'm just double checking, and I know that this is actually my solution. Okay, I'll show you one more quickly. Something that might look a little different this time. Here's another system, right? Again, always check x is lined up, y is lined up, equal signs are lined up, and constants are lined up. So I'm ready to go. If I add these two together, I get 6x, and here I have a negative 3y and a positive 3y, so those are going to cancel out. They're going to give me 0. Equals 24, right? Negative 2 plus 26. I know I can solve this by using inverse operations, and I get x is equal to 4, right? I'm now going to plug that 4 back into one of these. I'm going to pick this one again. It just looks a little bit easier, has no negatives in it. Remember, I can choose to plug it into either equation, but why not make the one that's easier? So in place of x, I'm going to put a 4. Okay. 2 times 4 is 8, plus 3y equals 26. I got to get y by itself, so I'm going to subtract 8 first. I have 3y is equal to 18. Right? Yep, 18. And then I need to divide by 3. And so y is equal to 6, right? So my solution is 4 comma 6. Okay, you are going to try and practice this on the other side. So you're going to flip this page over, and there's 4 problems to attempt on the back. Good luck.